Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, welcome to this series of videos about the electric car full design from scratch. The previous tutorial or video we showed the main idea of the electric car and its main components. In this video we're gonna continue showing these components but in details. This is the video about suspension system main components. So let's see. First, control arms, steering knuckle, ball joint, shock absorber, brake system, spindle, wheel rim, and tire. So here are the control arms. A control arm is a bar that has a pivot at both ends. Your car has several, including the upper control arm and the lower control arm. So we have upper and lower, which are arranged to form the letter A. Control arms are part of the suspension system. They attach suspension members to the chassis and manage the motion of the wheels so that it synchronizes with that of the body of the car. They work with bushings, which are cylindrical linings that reduce friction and restrain the auto parts from going every which way. As a result, you are able to go on joyrides without feeling sick and dizzy, as there is control and smoothness in the movement of the car. Gentlemen, before inventing the coils or adding the coil springs to cars, it was very uncomfortable situation, and you can see the difference between the modern car and the old cars or the cars that did not include any suspension or coils or springs. Okay, you can dig into this. So the two bottom points of the control arms that form the letter A are attached to the frame of the vehicle, while the top point is attached to the spindle. 3 or 4 control arms are placed between the rear axle housing and the frame if you have coil springs in both the front and rear suspensions. Like other body parts, the control arms should also be lubricated at every oil inspection. Handling and steering could become erratic if the control arms are malfunctioning, and the unsteady movements of your car could take away your riding comfort. That's why it's pretty important to know how to design these kind of things carefully. So this is the reference of this information, and here is a CAD model for the upper control arm from Grab CAD website. You can find the suspension system like I said, and as you can see, it is very beautiful. We have here fillets and this kind of stuff, and we have here places for bushings, and this is A. Okay, this is the A design, and this is the lower control arm. And if you search for these things, you will find that the old models we used the equal length arms, but nowadays the lower control arm has different length. You should know why. Okay, so now here is steering knuckle. Steering knuckle is that structure on the wheel hub to which the tie rod ends of the track rod transfer motion to the wheels. Okay, so tie rod ends and the track rod are the lengths of the steering system of the vehicle, which are designed according to a particular steering geometry. So as you can see here, the steering knuckle. So here is the steering knuckle. You can move this, or this rotates the wheel. The wheels will steer about this axis. Okay, to turn left or right. And here is the axis of rotation of the wheels. Okay, the wheel rotates like this, and here the knuckle can rotate around this. Why? To get the car to direct the car to the right direction or the left direction. Okay, so you can imagine from the above figure that when the steering knuckle moves right or left, the wheels rotate about an axis shown by the green axis. You will find various designs of a wheel hub. The purpose of the steering knuckle is to facilitate the steering of the vehicle by transferring the motion of the rack transferred from the rotation of the pinion due to the rotation of steering wheel to the wheels. This is connected to the steering system. We're gonna see the assembly in the next videos. So here is the front hub carrier from GrabCAD website. As you can see here, this is the knuckle attached to the wheel, and this is a part of the steering system. So if I here imagine the shaft which will rotate around its axis, and this will rotate to right or to the left, and this and so on. The tire will turn to left or right. Okay. Here is the ball joint. In an automobile, ball joints are spherical bearings that connect the control arms to the steering knuckles. So here is the control arm. How is the control arm connected to the steering knuckles using the ball joints? They are used on virtually every automobile made and work similarly to the ball and socket design of the human hip joint. A ball joint consists of a bearing, stud, and socket enclosed in a casing. All these parts are made of steel. The bearing stud is tapered and threaded and fits into a tapered hole in the steering knuckle. A protective encasing prevents dirt from getting into the joint assembly. Usually this is a rubber-like boot that allows movement and expansion of lubricant. Motion control ball joints tend to be retained with an internal spring, which helps to prevent vibration problems in the linkage. The offset ball joint provides means of movement in systems where thermal expansion, contraction, shock, seismic motion, and torsional motions and forces are present. A ball joint is used for allowing free rotation in two planes at the same time, while preventing translation in any direction. So notice that this is the main purpose of it. Okay, to free rotation to planes, but no translation in any direction, including rotation in those planes. Combining two such joints with control arms enables motion in all three planes, allowing the front end of an automobile to be steered, okay, and a spring and shock damper suspension to make the ride comfortable. So here is ball joints as you see. So the next videos we're gonna see the full details of each component and the design of it, okay, using the CAD models. Okay. Here the ball joints allow limited range of smooth movement in all directions. So as you can see, this is the rear wheel drive vehicle front double wishbone suspension with upper and lower ball joints and tie rods in shown. You can see this is the tie rod, and here is the knuckle. Okay, and here is, I guess this is the upper control arm, this lower control arm, or inside this. Okay, here is the ball joint to connect this to this steering knuckle. Again, so steering knuckles control arms to the steering knuckles. Okay. Now the shock absorber is one of the best things in the suspension. A shock absorber is in reality a shock damper. Is a mechanical hydraulic device designed to absorb and damp shock impulses. It does this by converting the kinetic energy of the shock into another form of energy, typically heat, which is then dissipated. Most of the shock absorbers are a form of dashpot, a damper which resists motion via viscous friction. So here is a shock absorber. We're gonna analyze it completely in some of the next videos and see how can we assemble it, okay, and each component. So it's based on this spring, okay, as this is the shock absorber. If you do not use it, you will not feel comfortable because the shocks gathered from the street or gathered from the road on uneven roads will directly transfer to the chassis. Pneumatic and hydraulic shock absorbers are used in conjunction with cushions and springs. An automobile shock absorber contains spring-loaded check valves and orifices to control the flow of oil through an internal piston. Okay, so one design consideration when designing on choosing a shock absorber is where that energy will go. So in most shock absorbers, energy is converted to heat inside the viscous fluid. In hydraulic cylinders, the hydraulic fluid heats up, while in air cylinders, the hot air is usually exhausted to the atmosphere. So there are two designs. So in other types of shock absorbers, such as electromagnetic types, the dissipated energy can be stored and used later. In general terms, shock absorbers help cushion vehicles on uneven roads. Gentlemen, I suggest watching the Mercedes videos about shock absorbers and Audi and the BMW or BMW to see how these companies do or think about making the driving comfortable. Okay. So here are the brake system. So your vehicle's brake system is designed to perform only one job, and that's to safely stop your vehicle. In order to do that, there are three key things needed: a vehicle operator, hydraulic pressure, and friction. So when the vehicle operator pushes the brake pedal down, the pedal levers and rods activate the power brake booster. The booster uses engine vacuum or pump to multiply the force from the operator's foot to the master cylinder. Hydraulic lines connected to the master cylinder go out to a proportioning valve or to the ABS Antilock brake system module, then to each either brake caliper if you have disc brakes or to the wheel cylinder if you have drum brakes. There are differences between the drum brakes and the disc brakes. The brake fluid in the lines flows into the calipers or wheel cylinders, and the hydraulic pressure pushes the brake pads against the rotor. The rotors of brake shows against the drums, causing friction which stops the vehicle. So this is the basic idea. So as you can see, the brake system of a car, where the brake line, we have here a piston, and here is brake pod, and this is the caliper, and here is the disc. So disc brake, okay. And you can see or watch a video on YouTube about how does this work. I'm gonna make a video, complete video about this in details and how to assemble it. Now the spindle in automobile, the spindle is part of the suspension system that carries the hub for the wheel and attaches to the upper and lower control arms. Spindle is referred to as an upright in UK built vehicles and in areas dominated by cars designed for the UK like Australia and New Zealand. A part of your vehicle's suspension system, the spindle is what attaches the wheel and tyre onto the steering system. It's usually located in at the front of a vehicle, although some types of front wheel drive cars are also equipped with rear spindles. So here is the spindle, and you can check out many CAD models of it. To be able to securely lay the wheel and tyre onto the steering assembly, this part pivots on a strut or between the lower and upper A-frames and holds the outer and inner wheel bearings in position. So we're gonna see also later how to assemble this part. I'm just showing you the whole ideas, or the basic ideas. There are several considerations when designing a spindle. Loads and forces need to be considered, of course, to be able to handle your car's weight and the constant amount of friction this component is regularly exposed to. It is usually made from forged steel. So you have to know what is the best material to produce this part from the most recent research papers. You have to get research papers, by the way. Although spindle and axles have a similar purpose, spindles are sometimes used on farm equipment and trailers instead of heavy-duty axles. This is because spindles can better handle extremely heavy loads. The use of spindles on machinery also leads to improved side-by-side movement of the suspension system and tires. And here is the reference. So now is the wheel rim. The rim is the outer edge of a wheel holding the tire. It makes up the outer circle design of the wheel on which the inside edge of the tire is mounted on vehicles such as automobiles. For example, on a bicycle wheel, the rim is a large hoop attached to the outer ends of the spokes of the wheel that holds the tire and tube. You can see the difference between this and the car. So we have here the scratched rim on a one-piece alloy wheel. The black residue remains from where the tire was seated on the safety profile rim. Okay, you can check this out on Wikipedia. Also, we're gonna make a detailed video about the rim and the parameters of the design. It's pretty important. In cross section, the rim is deep in the center and shallow at the outer edges, thus forming a U shape that supports for the bead of the tire casing. So the first pneumatic tires for bicycles were simple tubes in shape secured to the wooden outer concave surfaced circumference of the wheel by glue and air pressure pressing them against it. The surface for receiving the tube was not very secure, thus causing the tire to sometimes come off the rims. So you have to take care of this point to avoid these problems. So bicycle manufacturer and inventor Thomas B. Jeffrey developed an improved tire with a wire that was embedded in the rubber of the tire, and the wire could be tightened onto the rim. So in 1882, a patent became the ancestor of all clincher tires, the design found on modern bikes and cars. Contemporary clincher tires today have wires embedded on both beads of the tires, so wires fit inside the edges of the rim to hold the tire in place when it's fully inflated. So the annual effective is the distance between the bead seats for the tire as measured in the plane of the rim and through the axis of the hub, which is or will be attached or which is integral with the rim. And width is the effective width, separation distance between opposed rim flanges. The flange to flange width of a rim should be a minimum of 3/4 of the tire section width, and the maximum rim width should be equal to the width of the tire thread. Okay, so we're gonna see these details later using CAD models. Type depends on the type of vehicle and tire. There are various rim profiles as well as the number of rim components, so you have to know which type you should use. Reference from this Wikipedia. Now the tire in American English, and this tire British English is ring or is a ring-shaped component that surrounds a wheel's rim to transfer a vehicle's load from the axle through the wheel to the ground and to provide traction on the surface traveled over. So most tires, such as those for automobiles and bicycles, are pneumatically inflated structures, which also provide a flexible cushion that absorbs shock as the tire rolls over rough features on the surface. Tires provide a footprint that is designed to match the weight of the vehicle with the bearing strength of the surface that rolls over by providing a bearing pressure that will not deform the surface excessively. The materials of modern pneumatic tires are synthetic rubber, natural rubber, fabric, and wire, along with carbon black and other chemical compounds. Also Wikipedia. And we have here so this is the tire. They consist of a tread and a body. The tread provides traction, while the body provides containment for a quantity of compressed air. So you can see here this kind of thing. We have here treat, and we have the okay, the other component, treat and the body. Before rubber was developed, the first versions of tires were simply bands of metal fitted around wooden wheels to prevent wear and tear. So okay, we have here just finished this video. We're gonna analyze these kind of details in separate videos. So please, thank you very much. So please watch and be ready for the next videos. We covered some information in these videos about control arm, steering knuckle, ball joint, shock absorber, brake system, spindle, wheel rim, and tire. We're gonna make separate videos for these components to see how to design them carefully. Okay, thank you very much. Assalamu alaikum warahmatullahi ta'ala wabarakatuh.